Straight-rated 480-volt breakers are sufficient for corner-grounded delta systems. Corner-grounded systems typically have one phase grounded at the source. Because of this, the energized phases are referenced to ground. Therefore, straight-rated breakers are used as they are designed for grounded systems. A standard delta-Y transformer will function normally with a grounded primary phase. The transformer does not care which phase is grounded. The transformer converts the three-phase input to the desired single-phase output. Use 3-pole mains. A 2-pole main would only protect the ungrounded phases. This leaves the grounded phase unprotected. A 3-pole main will protect all three phases. There are additional considerations to remember. The grounded primary phase should be bonded to the neutral at the transformer. This provides a path for fault currents. It ensures that the grounded conductor is at ground potential. The grounding rod should be installed. It should be connected to the neutral bond to ensure a proper grounding system. The equipment should be clearly labeled. This indicates that it is a corner-grounded system. This alerts personnel to the potential for 480 volts to ground on two phases. Ensure that all personnel working on the system are properly trained. Training on the hazards and safety precautions associated with corner-grounded systems is important. While corner-grounded systems are uncommon, they are safe and reliable if properly installed and maintained. By following the guidelines, you can ensure a compliant and safe electrical system. A corner-grounded delta system is a type of three-phase electrical system where one of the phase conductors is intentionally grounded. This configuration differs from the more common Y-connected system where the neutral point is grounded. Understanding the nuances of a corner-grounded delta system is crucial for ensuring safety and proper operation. Firstly, let's talk about the grounding. In a corner-grounded delta system, one of the three-phase conductors is directly connected to ground. This grounded phase is often referred to as the corner of the delta. This grounding provides a reference point for the system voltage, ensuring that the voltage between any ungrounded phase and ground does not exceed the system's nominal voltage. Secondly, concerning breakers, the use of straight-rated breakers is generally acceptable in corner-grounded delta systems. A straight-rated breaker is designed to interrupt the circuit's full rated voltage. In a corner-grounded delta system, the voltage to ground in the ungrounded phases is the same as the phase-to-phase voltage. Therefore, a 480-volt straight-rated breaker is suitable for a 480-volt corner-grounded delta system. Slash-rated breakers are typically used in single-phase systems where the voltage to ground is lower than the phase-to-phase voltage. For instance, a 120/240-volt slash-rated breaker is commonly used in residential applications. Thirdly, consider transformers. Standard delta-Y transformers can indeed be used with a corner-grounded delta primary. The transformer operates on the principle of electromagnetic induction. It does not inherently depend on which specific phase is grounded. The primary winding configuration of the transformer, being delta, is designed to accept a three-phase input. The secondary winding, typically Y-connected, provides a three-phase output with a neutral point. This allows for both phase-to-phase and phase-to-neutral loads. It is essential to ensure that the transformer is properly sized and rated for the specific application. Fourthly, discussing the use of mains, 3-pole mains are recommended for corner-grounded delta systems. The purpose of a main breaker is to protect the entire electrical system from overcurrents and short circuits. In a corner-grounded delta system, grounding one phase means that a fault on any of the three phases can result in a high fault current flowing back to the grounded phase. Using a 3-pole main breaker ensures that all three phases are protected. This includes the grounded phase. A 2-pole main breaker would only protect the two ungrounded phases, leaving the grounded phase vulnerable to overcurrents. Fifthly, grounding and bonding are critical in corner-grounded delta systems. The grounded phase conductor must be securely bonded to the equipment grounding system. This bonding ensures a low impedance path for fault currents to flow back to the source, facilitating the quick operation of overcurrent protective devices like circuit breakers or fuses. The equipment grounding system should include a grounding electrode system. This might involve ground rods, ground plates, or connections to a metallic water pipe. This grounding electrode system provides a stable reference to earth potential. It helps to minimize voltage fluctuations and protect against electrical shock hazards. Sixthly, when installing a corner-grounded delta system, it is crucial to use appropriate warning labels and signage. These labels should clearly indicate that the system is a corner-grounded delta configuration. They should also warn about the potential for having the full phase-to-phase voltage present between the ungrounded phases and ground. Proper labeling helps prevent accidental contact with energized parts. It alerts personnel to the specific hazards associated with this type of system. Seventhly, training is paramount. Ensure that all electricians, technicians, and other personnel who may work on the corner-grounded delta system receive proper training. This training should cover the specific characteristics of corner-grounded systems. It should emphasize the importance of following safety procedures and using appropriate personal protective equipment. Training should also cover troubleshooting techniques. This is to address common issues that may arise in these systems. Eighthly, when working with corner-grounded delta systems, specific safety precautions should be observed. Always verify the absence of voltage before working on any electrical equipment. Use properly rated personal protective equipment. This includes insulated gloves, safety glasses, and flame-resistant clothing. Follow lockout-tagout procedures to ensure that the circuit is de-energized and cannot be accidentally re-energized while work is in progress. Avoid working alone whenever possible. Ninthly, consider the advantages and disadvantages of corner-grounded delta systems. Some advantages include simplicity and cost-effectiveness. These systems typically require fewer components compared to other grounding schemes. Corner-grounded delta systems can offer enhanced system protection in certain industrial applications where ground faults are more common. Disadvantages include the potential for higher voltage stress on insulation. This is due to the full phase-to-phase voltage being present between the ungrounded phases and ground. Troubleshooting can be more complex. This is compared to other systems. Because of the unique grounding configuration, it can present a higher risk of electric shock if proper safety procedures are not followed. Tenthly, national electrical code requirements must be considered. The National Electrical Code provides specific guidelines for the installation and maintenance of corner-grounded delta systems. These guidelines cover aspects such as grounding electrode requirements, conductor sizing, overcurrent protection, and wiring methods. Adherence to the National Electrical Code is essential for ensuring the safety and compliance of the electrical system. 11thly, when selecting equipment for use in a corner-grounded delta system, make sure that the equipment is rated for the system voltage and grounding configuration. Use only equipment that is listed or labeled by a recognized testing laboratory. This ensures that the equipment meets applicable safety standards and is suitable for the intended application. Inspect all equipment for damage or defects before installation. Replace any damaged or defective equipment to prevent potential hazards. 12thly, documentation is critical. Maintain accurate and up-to-date documentation of the corner-grounded delta system. This documentation should include a detailed wiring diagram, a list of all equipment used, and records of any inspections, testing, or maintenance performed. Keep the documentation readily available for reference by qualified personnel. This facilitates troubleshooting and ensures the ongoing safety and reliability of the system. 13thly, when commissioning a corner-grounded delta system, perform thorough testing to verify that the system is operating correctly. This testing should include insulation resistance tests, ground impedance measurements, and voltage and current readings. Address any issues identified during testing before placing the system into service. Proper commissioning ensures that the system is safe and reliable. 14thly, the selection of appropriate overcurrent protection devices, such as fuses and circuit breakers, is crucial for ensuring the safety and reliability of a corner-grounded delta system. These devices are designed to protect the electrical system from overloads and short circuits by interrupting the flow of current when a fault occurs. The overcurrent protection devices must be properly sized and coordinated to provide adequate protection without causing nuisance tripping. Fuses are typically selected based on their current carrying capacity and interrupting rating. Circuit breakers are selected based on their current rating, voltage rating, and interrupting capacity. The interrupting rating of the overcurrent protection device must be greater than the available fault current at the point of installation. 15thly, regular maintenance is essential for ensuring the long-term reliability and safety of a corner-grounded delta system. Maintenance activities should include periodic inspections of all electrical equipment, testing of overcurrent protection devices, and tightening of connections. Inspect conductors for signs of wear, damage, or corrosion. Replace any damaged or deteriorated conductors to prevent potential hazards. Clean electrical enclosures to remove dust, dirt, and debris. This helps to prevent overheating and ensure proper ventilation. 16thly, consider surge protection. The installation of surge protection devices is recommended to protect sensitive electronic equipment from voltage surges caused by lightning strikes, switching events, or other transient disturbances. Surge protection devices divert excess voltage away from the protected equipment, preventing damage or malfunction. Select surge protection devices that are rated for the system voltage and grounding configuration. Install surge protection devices at the service entrance and at individual equipment locations as needed. 17thly, ground fault protection is an important consideration for corner-grounded delta systems. Ground fault protection is designed to detect and interrupt low-level ground faults that may not be detected by conventional overcurrent protection devices. Ground fault protection can help to reduce the risk of electrical shock and prevent equipment damage. Ground fault protection is typically required for services rated 1000 amps or more. 18thly, harmonic distortion can be a concern in corner-grounded delta systems, particularly in industrial facilities with nonlinear loads such as variable frequency drives, electronic ballasts, and switching power supplies. Harmonic currents can cause overheating of transformers, conductors, and other electrical equipment. They can also interfere with the operation of sensitive electronic devices. To mitigate the effects of harmonic distortion, consider using harmonic filters or reactors. These devices are designed to reduce the amplitude of harmonic currents and voltages. 19thly, when making modifications or additions to an existing corner-grounded delta system, it is important to ensure that the modifications comply with all applicable codes and standards. Consult with a qualified electrical engineer or contractor to ensure that the modifications are properly designed and installed. Update the system documentation to reflect any changes made to the electrical system. 20thly, consider the use of isolation transformers. Isolation transformers provide a means of isolating sensitive electronic equipment from the electrical system. Isolation transformers can help to reduce noise and interference, improve power quality, and protect against ground loops. Select isolation transformers that are rated for the system voltage and grounding configuration. Install isolation transformers at individual equipment locations as needed. 21st, it's essential to be aware of potential sources of electrical noise in corner-grounded delta systems. Electrical noise can interfere with the operation of sensitive electronic equipment. It can also cause data corruption and communication errors. Sources of electrical noise include electromagnetic interference, radio frequency interference, and ground loops. To minimize electrical noise, use shielded cables, filters, and proper grounding techniques. 22nd, when troubleshooting problems in a corner-grounded delta system, start by visually inspecting the system for any obvious signs of damage such as loose connections, damaged conductors, or overheated components. Use a multimeter or other test equipment to check voltages, currents, and resistances. Consult the system documentation for wiring diagrams and troubleshooting procedures. If you are not comfortable troubleshooting the system yourself, contact a qualified electrician or electrical engineer. 23rd, proper grounding is essential for ensuring the safety and reliability of a corner-grounded delta system. The grounding system provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to quickly interrupt the circuit and prevent damage or injury. The grounding system should be designed and installed in accordance with applicable codes and standards. Regularly inspect the grounding system to ensure that it is in good condition and functioning properly. 24th, the use of appropriate personal protective equipment is essential for protecting workers from electrical hazards when working on corner-grounded delta systems. Personal protective equipment includes insulated gloves, safety glasses, and arc flash rated clothing. Select personal protective equipment that is rated for the system voltage and working conditions. Inspect personal protective equipment before each use to ensure that it is in good condition and free from defects. 25th, lockout-tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair work on corner-grounded delta systems. Lockout-tagout procedures involve disconnecting the equipment from all sources of energy and installing a lock and tag to prevent the circuit from being accidentally re-energized. Follow lockout-tagout procedures whenever working on or near energized electrical equipment. 26. The installation of ground fault circuit interrupters can provide additional protection against electrical shock hazards in corner-grounded delta systems. Ground fault circuit interrupters are designed to detect small ground faults and quickly interrupt the circuit, preventing electrical shock. Install ground fault circuit interrupters in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. 27th, be aware of the potential for arc flash hazards in corner-grounded delta systems. Arc flash is a dangerous phenomenon that can occur when a short circuit or other electrical fault creates an explosive release of energy. Arc flash can cause severe burns, injuries, and even death. Perform an arc flash hazard analysis to determine the potential for arc flash at various locations within the electrical system. Use appropriate personal protective equipment and follow safe work practices to minimize the risk of arc flash. 28th, when working on energized electrical equipment in a corner-grounded delta system, use insulated tools to prevent accidental contact with energized parts. Insulated tools are designed to provide a barrier between the worker and the electrical current, reducing the risk of electric shock. Inspect insulated tools before each use to ensure that they are in good condition and free from defects. 29th, consider the use of remote racking devices for circuit breakers in corner-grounded delta systems. Remote racking devices allow workers to operate circuit breakers from a safe distance, reducing the risk of exposure to arc flash hazards. Remote racking devices are particularly useful for high voltage or high current circuit breakers. 30th, the key is always to prioritize safety and ensure that all work is performed in accordance with applicable codes, standards, and safety procedures when dealing with corner-grounded delta electrical systems. Always consult with qualified professionals if you have any questions or concerns.